Let's talk now about comparing different types of these same distributions. So in the M&M colors example we looked at before, we might want to know if the types are different. That is, maybe our regular M&Ms and mini M&Ms different colors. But do you expect or want an even distribution in each? What is the bigger concern here? Generally, the distribution itself is less important than the comparison. You may not necessarily be interested in what proportion of M&Ms are red, but you may be interested in whether regular M&Ms and mini M&Ms are different distributions of colors. So if we use this data here, we have a column with counts of regular M&Ms. So this is the M&Ms we observed when we counted out of a bag of regulars. And these are the counts when we counted out of a bag of mini M&Ms. So we can look at the proportion within each that match each color. So about 14% of regular M&Ms are blue, and about 21% of mini M&Ms are green. So you can see that these values differ a little bit between the two columns. But the real question is, are these differences meaningful? To test that, we can still use the chi-square test with some tweaks. First, we need to figure out the expected. So we always need to use count data for our chi-squared. We recall that the formula is observed minus expected squared over the expected, which means we need the expected values. But how? What does it mean to have an expected value for this type of a distribution? Well, the simplest way is to find the row, or column, percents, and multiply it by the column, or row, totals. Doesn't matter which order you do this in, the same mechanics apply and you'll get the same answer. Here, for example, we can show that 16% of all of the M&Ms are blue. 16% are brown, 19% are green, 17% red, 14% red, 18% yellow, for a total of 1. Because remember, proportions always sum to 1 when it fills the sample space. So now what we want to do is take the 42 regular M&Ms, and what we're saying is that if the distribution of regular and mini M&Ms was the same color, or the same distribution of colors, 16% of our regular M&Ms should be blue. 16% of our mini M&Ms should be blue. So we take that and multiply each of these values out, and we get this table for our expecteds. So because our row sums here are 15, we expect that we'll always get those same row sums, we'll always get those same column sums. So our expecteds are a little bit different because we have fewer regular than mini M&Ms. This is perfectly okay for a chi-squared test. But now we want to find the differences. So we have our observeds, we have our expecteds. We want to use the formula to calculate the chi-square statistic. So remember, this is observed minus expected squared over expected for each and every one of these entries. Now I'm not going to make you do these 12 by hand, I've got them done ahead of time. We can take these contributions, so this is the value of observed minus expected squared divided by expected for regular blue M&Ms. And we sum those all up and we can get a test statistic out. So our chi-square stat is 2.502, our degrees of freedom is 5, okay, and our p-value is 0.776. So we fail to reject the null hypothesis. The null hypothesis in this case, remember, is that there is no difference between the distribution of regular and mini M&M colors. Now in StatCrunch, we can do this, by, I will put that in a separate video.